Hi, Archie. This is take 2. That means we're trying it again. Ready? Take 2. Hi, Archie.
Hi.
Friday evening. Are you ready for the weekend?
Yeah.
I hear you are doing something kind of exciting tomorrow.
Yes, I know.
Do you? So it's not a surprise?
Yes.
Do you know what you're going to do early tomorrow morning?
Yes, because I hear my mom and my dad's phone calling my friend.
Is your friend going with you?
Yes.
It's going to be a long climb, right? Up a mountain?
Yes. And down the mountain.
Maybe 4 or 5 hours?
6 or 7 hours.
Oh, I want to see a picture from the top. How about that?
Okay.
Okay. Let's see where our friends are. Okay. Let's see what's going on here. So Doc Culpepper has just told the class not to worry because experiments have shown that coral reefs can be restored. So on the page before, she was saying, boy, coral reefs are dying because the ocean temperature is getting a little warmer because of global warming. And so everything was sad. But then she said, don't worry, coral reefs can be restored. There has been some experiments done to show this. She says, this is done in a variety of ways. Variety means more than one way. The most common way is to grow new coral in laboratories like this one. Remember, coral is a plant and plants can grow. When the coral is strong enough, it's transported to the ocean. I just said that coral is a plant, and then I asked myself, do I know that for sure? Is coral really a plant or is it an animal? And I wasn't sure about the answer to that, so I decided I would double check. I know it's a living thing because I know it can grow. So I went to Mr. Google and found out from the National Geographic Society that although coral may look like a colorful plant growing from roots in the sea floor or the bottom of the ocean, it is actually an animal. I was wrong. Corals are known as colonial organisms. I'm not sure what that means because many individual creatures live and grow while connected to each other. They are also dependent on one another for survival, for living. I do look at this word now that I saw a hint. It said because many individual creatures live together. Now when I look at colonial organisms, I know something. Organism is what we call something that is living. Colonial has, I notice it has this part here, and that is related to this word here, colony. There are 2 places where I have heard of a colony before. One is back here when we were looking at a petri dish and we were looking at the different bacteria that grew on the petri dish. And something I didn't tell you that day is that each one of these circles, like this one right here, I put a black circle around it, and this one right here, this orange one, I put a circle, and this one. These are called colonies. IES means more than one. This one right here is one colony, a colony of bacteria. It would begin with just one bacteria of that type of bacteria, just one, and then it would reproduce and become more and more and more and more. So by the time it has grown enough and reproduced enough to make a big circle that we can see with our eyes, there might be thousands, or I don't know if there's even millions, I don't know, but because one bacteria is not something we can see with our eyes. It is microscopic. We would need a microscope to see, here's the microscope, to see the bacteria. But if there are thousands, or I would probably need to research how many bacteria can be in one colony on a petri dish. But here, when we are looking at one colony of bacteria, this has been growing for at least a day, maybe a few days, and that one bacteria has multiplied and become 2 and 4 and 8 and 16, and just kept dividing and multiplying and becoming more and more. But it all came from the same one bacterium. So everything, every bacteria in this colony is the same kind of bacteria because it came from just one. So we call it on the petri dish a colony. The other time I have heard the word colony is when I was learning about history in the United States. And back when people first started coming to the United States from England, before it was called the United States, before it was a country, when the very first Europeans were crossing the Atlantic Ocean and coming over to what they called the New World, and they started setting up towns and places and camps to live together. And so before we had a state or 13 states or 50 states, we had 13 colonies. And a colony was like a town where a bunch of people lived together. So colony is when there's a bunch of something living together. So in coral, we have a bunch of these very small organisms. They said individual creatures that are living together. And then what we see with our eye is the coral, but that's actually many small organisms that are living together. That is why they call it a colonial organism. It is like a colony. It's sometimes fun when you are looking at Google to see what questions people have. This question is, what kind of animal is coral? And it says, unlike plants, corals do not make their own food. Plants can make their own food, but coral cannot because it's an animal. It says the branch or mound that we often call a coral is actually made up of thousands of tiny animals called polyps. A coral polyp is an invertebrate that can be no bigger than a pinhead to up to a foot in diameter. Diameter is when we take a circle and we measure from one side of the circle to the other side of the circle, exactly in half. And that is called the diameter. A foot is 12 inches. And I thought this question was kind of fun. It said, does coral have a brain? Well, the cerebral looking organism, it does look a little bit here like a brain, doesn't it? When we've seen pictures of brains, it looks a little bit like that. Cerebral, this word right here, means, cerebral means about the brain. And so the cerebral looking organism does look a little bit like a brain, but it says they do not have brains, but they can grow 6 feet tall. That's about 2 meters, and live for up to 900 years. They are found in the Caribbean, the Atlantic Ocean, and the Pacific Oceans. Brain corals they are found in the Caribbean, or I'm not sure if this is called the Caribbean or the Caribbean. I've heard it both ways, but they are found here and also in the Atlantic Ocean and the Pacific Ocean. All right, so now I know that coral is an animal, but it is a living thing, so it can grow. I have to remember it really is a colony of living things called polyps that all live together and grow together. So it says the most common way is to grow new coral in laboratories like this one. When the coral is strong enough, it is transported to the ocean or taken to the ocean. Harper gazed down at her petri dish. Her piece of coral shimmered, that's kind of like glistened or sparkled, with droplets of salt water. I would like us to perform an experiment, said Doc. Each of you has an identical piece of coral. So everyone has the same kind of coral and it looks the same. I would like you to place your coral in your aquarium and measure its growth. So they will be measuring it every time they come back to the lab. They will take a measurement to see how long is it. Everyone's water will be slightly different in the aquarium. Yours might be warmer, saltier, or more acidic, this word is acidic, than your neighbors. In this way, we will determine the best conditions for growing this particular type of coral. Okay, so everyone is going to have an aquarium, but in every aquarium, the water will be a little bit different. Some will be warmer, some cooler, some saltier, some less salt, some more acidic, and some less acidic. So they are going to measure how much their coral grows. And they're going to see in which aquarium does the coral grow the best. And then they will know that the water in that aquarium is best for that type of coral. So let's get started. Awesome, Theo said, grinning at Harper. This should be fun. I don't know about fun, Harper said. It sounds very serious to me. Theo dropped his smile. Well, a smile is not something we actually pick up and then drop on the floor. When we say we drop our smile, it just the sides of our mouth go from being up high smiling to sad.
Like this.
Perfect. That's exactly so. Sure, the problem is serious, he agreed, but maybe we will be the ones to help fix it. Harper liked the sound of that. You're right, she said. I'm sorry, I didn't mean to be negative. Harper tried to stay optimistic. We will look at this word in just a moment. She knew science often held the answers to some of the world's biggest and scariest problems. That's why she loved science to begin with. Some days, though, it felt like the problems kept piling up. We're going to look at two things. One is the meaning of optimistic. Can you say this word? Optimistic.
Optimistic.
Good. Now I want you to get this P right here a little bit more. Optimistic. like the end of the word top, optimistic. Not this one. Optimistic.
Optimistic.
Perfect. Great. Well, optimistic is a great word. It means being really positive and looking on the bright side. It means looking for the silver lining in the cloud. It means looking at the situation that has a lot of things that are bad, that are not what we want. And we could be disappointed, but we say, you know what, we're going to look for the bright side. We are going to have hope. We are going to be thankful. We are going to look for the things that are great and that can give us hope that something even better will happen. So it's about being positive. And so we've talked about this before. We use the battery. And on the battery, you see this end that has the minus, we say is negative. And this end that has the plus sign, we say is positive. So we use the minus for negative and the plus for positive. Have you ever made a circuit using a battery? With a circuit, you can have a little motor and turn on the motor. You would need this switch right here to be closed. And so it would come down and connect to this side. And then you would be able to have a little motor. So here is, or you could make a light go on. So here is the positive end of the battery and the negative end. Well, we also use this word when we're talking about attitude. Attitude is, how do we look at life? How do we look at the things that happen to us? How do we look at our day? How do we look at tomorrow? Are we going to be hopeful or are we going to be discouraged and sad? For example, if we're going hiking on a mountain the next day and the weather forecast is for some rain, someone who is pessimistic, that means not hopeful, they might say, oh, great, our whole trip is ruined. We will have a horrible time. There will be a mudslide. We'll have to turn around. Oh, this is not going to be fun at all. They are being pessimistic. Someone who is being optimistic or positive, they would say, oh, even if it rains, we will still have fun. Okay, so a person who has a positive attitude, we say, is an optimist. So the person is an optimist. So optimist is a noun. We can add the IC at the end and use it as an adjective or a character trait to describe a person who has a positive attitude. And we say that person is optimistic. They're looking for the bright side. They are having hope. They're looking for the things to be thankful for and excited about and believe in. They are not letting the circumstances or the situation or things that happen ruin it for them and make them feel unhappy and discouraged and disappointed and hopeless and say, oh, everything is ruined. This will never work. Someone who has a negative attitude, we say, is a pessimist. Pessimist is a noun. We would call the person a pessimist. If we add IC, it becomes an adjective or a character trait to describe that person who has a negative attitude. The pessimistic person just complains and feels sad and thinks everything is going to be miserable and not work out. And they think the worst possible things will happen. And they do not have hope. They do not feel thankful for things. They see everything as a potential problem. So those are some great words, optimistic and pessimistic. They describe people and what kind of attitude we have. Only people can be optimistic or pessimistic. Other animals and plants, they cannot look at life and think about it as an optimist or a pessimist. Doc Culpepper said they are going to be taking measurements. When we are working in a laboratory, the scientist wants to collect numbers and look at the numbers. When they are doing an experiment, they like to have measurements that they can take. That gives them numbers. And then as they are doing the experiment, they look to see how the numbers change. So they take numbers at the beginning and measure things, and then they are going to change something. And then after they change something, they take numbers, they take measurements again, and they see if they are the same or different. If they are different, then they decide whether or not that one thing they changed is what caused the difference. So I have a few pictures I want to show you. Here's a picture of a science lab at a school. And so you can see there is lots of different equipment for the students to use. Here is another picture of a science lab at a school. You can see where each student sits. There is water, a water faucet, and a sink. Here is another picture of a science lab at a school. The science labs are usually set up so that a group of students can work together. Maybe 2 or 3 or 4 students can be lab partners and work together on an experiment. Here are some of the things that you might see in a science lab, such as a microscope and petri dishes and glass flasks and test tubes. Here's another microscope. Here are some students working together on an experiment. They have their safety goggles on. Here are some other students working together on a science experiment. When you are working in a science lab, you take lots of measurements. We need tools to use for taking measurements. Here are some examples of tools that you might use. You might use a thermometer to take the temperature. You might use a graduated cylinder to measure a volume of water. You might use a scale like this one. There's 4 scales here that are going to measure the mass, the number of grams of something. You might use a ruler or a measuring tape to measure how long something is. You might be measuring the amount of time that something takes. You might be using a thermometer to measure temperature. If you want to take the temperature of a person, some thermometers can just kind of point it at their forehead. Some go in the mouth. Some go in the ear. This thermometer will just measure the temperature in the room. This thermometer can be used to put into something and to measure the temperature of it. For example, this is a thermometer that they might use to measure the temperature of the water in the aquarium. Something else that can be measured is the pH. One of the things that Doc Culpepper said is that some of the water in their aquariums will be more or less acidic. The word acidic comes from this word, acid. The more acidic something is, we take the word acid and we add IC. Just like we turned optimist into optimistic or pessimist into pessimistic, we can take acid, which is a noun, a thing, and add IC, the suffix, and acidic will be an adjective describing how strong is the acid. Well, you can see here there are 14 numbers going from here all the way up to here. Number 7 in the middle is called neutral. From 1 to 6 is an acid. Number 1 is the strongest acid, so it is more acidic or very acidic. Number 6 is a weak acid. It's only a little bit acidic. It is less acidic than number 1. 14, from 8 to 14, we call a base. Here I am a day later. We didn't have quite enough time for the very last little bit I wanted to talk about for this page. Doc Culpepper had been explaining the experiment that everyone was going to do. She was giving everyone a piece of coral to put into an aquarium. And in their aquarium, their water would be just a little different from everyone else's water. And they wanted to see which coral grew the best. So they will be measuring the growth of the coral. And then when they find out whose coral grows the best, they can look to see, well, what was that person's water like? Some of the ways that the water was different was in the temperature of the water. Some might be warmer, some might have more salt or less salt, and some might be more acidic or less acidic. The one piece we didn't get to talk about yet was this part here. What does it mean to be more acidic or less acidic? And we started, and we did talk about how, just like with the word optimistic and pessimistic, the word acidic ends with that suffix ic, and it gets added to the noun, which is acid. Well, what is an acid? We have something called the pH scale, and this ranges from a measurement of 1, a pH of 1, up to a pH of 14. Number 7 is right in the middle, and this is what we call neutral. So this would not be an acid or a base. Something that is neutral is pure water. If we look at things that are 1 through 6, that would be an acid, the inside of our stomach, there is a type of acid inside of our stomach that when we eat food and that food goes into our stomach, that acid in our stomach can break the food down into tiny little pieces that are ready to be sent all over our body. That is very acidic because it is a pH of 1. A pH of 2 would be lemon juice. A pH of 3, an example is apple juice. Tomato juice is an example of 4. Black coffee would be 5. Milk is 6. If we look at the other end of the pH scale, going from 8 to 14, an egg would be a pH of 8. Baking soda is a pH of 9. Hand soap, a pH of 10. Ammonia is 11. Bleach is 12. And here's another pH scale. Let's see if we see any examples here that we haven't seen. The stomach acid here, they have listed as a 1. Lemon juice is 2. Here they have vinegar as a 3. You know, it's interesting if you've ever done that experiment to make a volcano and you mix vinegar with baking soda and then you get a volcano. Well, one is an acid and the other one is a base. Let's see, we had tomato juice and a banana and milk. Number 7 is pure water. Here is, going up here is blood, baking soda, broccoli, soap, bleach, drain cleaner. A lot of the cleaners that we use in the house are up in here, and we would not want to put these into our body. Our body needs to be right around a pH of 7, I think, unless it's inside the stomach, and then it is a pH of 1, and that helps break down the food. So right here in the middle, we say it's neutral. And as the pH gets lower and lower, we say it's more and more acidic. And as the pH gets higher and higher, we say it's more alkaline. Now I think of the experiment to make a volcano with the acid and the base, with the vinegar and the baking soda. When you take an acid and you add a base, you're going to get a salt and water for your products. Well, how does that work? Let's see. An acid is going to have hydrogen and chlorine in it. We call that HCl. A base is called NaOH. It's going to have Na, which is sodium, and OH, which is hydroxide. When we combine these together, look what happens. This chlorine and this sodium go together here, and we have sodium chloride. Well, sodium chloride, NaCl, is salt. Well, what's left? We have the hydrogen and the hydroxide. Well, those go together. Here it is. And they make H2O, which is water. And so when we combine the acid and the base, the molecules inside rearrange, and we end up with a salt and water. Here's another picture of that. So an acid we say is HCl. That is a hydrogen atom and a chlorine atom. A base we say is NaOH. That's an atom of sodium and an atom of hydroxide. But when we mix them together, the sodium and the chlorine, chloride, or is it called chloride? Sodium chloride. I think chloride and sodium, they go together, they mix together, and they become NaCl, sodium chloride, and that is salt. Plus what's left is the hydrogen atom and the hydroxide. Well, there's an H and another H, makes two H's, or H2, plus the O. H2O is water. Now, one way to tell what the pH of something is, this is the measuring part, because this page is about how we can measure things, is you can take this piece of paper here. It's called an acid-base indicator. You could put it into the aquarium water, and then it will change color. And then you hold up the color to this piece of paper back here, and you see what does it match. And what it matches to will tell you the number of the pH. This paper right here, we are going to see it right here. So it is the universal pH paper. And then when the color changes, you just compare it to this chart and you say, oh, it's number 12. So the pH is 12. The other way to do is to use blue litmus paper and red litmus paper. When you put blue litmus paper into an acidic solution that has a pH of 1 to 6, then the acid will convert or change the blue litmus into red. So this blue paper will turn red in an acid solution. Over here with the red litmus paper, if you put that into a solution that is a base and the pH is greater than 7, then the paper will turn blue. So the base will convert or change the red litmus paper into blue. And so these papers are something we can put into the water or the solution and help us find out what is the pH. And is it an acid or is it a base? Is it a strong acid, which would be 0, 1, 2, 3 would be a strong acid, or is it a strong base, 12, 13, 14? So this is an example of how we can measure the pH. We take the paper and we put it in and we watch the color change, and then we can find out, is it an acid or is it a base? So there are many different tools that a scientist can use to take measurements, and that gives him or her data, numbers, and we can watch to see if the numbers change when doing the experiment. And if the numbers do change, then we can figure out, well, what caused the change? And that is how we start to make theories and conclusions. So long, cheddar chips.